Hey, what's up, guys? In this video, we're going to test. We have this function here. We want to test whether the function increases, decreases, has a local max and minimum using the first derivative. This is our function f of x equal to x cubed minus 3x squared minus 24x plus 6. We already had a graph of the two functions here. Of the function here. The graph of the function, the blue one is the function itself, and the red one is its first derivative. So that's what we need to do here to test these different element, like discussing the function. Okay. First of all, we want to find the zero of the function, and to do that, we would take the first derivative and then work it out. F prime of x equals to 0. Now we're going to solve the first derivative of the function f of x is f prime of x equals to 3x to the 2 minus 6x minus 24, and we will solve this equation equals to 0 to have the zero of the function. So we have 3x squared minus 6x minus 24 equals to 0. But this equation here, we want to solve this for x. And to do that, we will first divide by 3, okay, to bring this back to a normal, to a standard quadratic equation. So we need to divide it by 3 right here. And that's giving us 3 factor. Okay, I put a factor 3 here. 3 factor as a factor, right? X squared minus 2x minus 8 equals 0. And this is the equation we want to solve for x, to have the zero of the functions of the function, this function here. So the solution to this equation are x equals minus 2 and x equals 4 equals to 4, right? So I use the discriminant to do that, but you can even use complete square or whatever you want. If you really don't understand that, refer to my other videos about solving equations, so you see how it works. So this is our solution to this equation, and these are the zero of my function. So you can check here on the function, see that the blue one, which is the original function, we have minus 2 is a zero of the function, and we have 2 here, right? I mean minus 2 and 4, that's what we got here, not 2 here. Minus 2 and 4, okay? This is the zero of the function of our first derivative. Therefore, we can write f of x equals to x plus 2 times x minus 4. So next thing to do here, we're going to look at the sign of the derivative f of x. You can use a number line or table of sign or everything, every kind of mean you want, okay, to do that. But myself, I'm going to use a table of sign, and this is what we're going to do right now. Now this is our table of sign with the sign of f of x. As you can see, any value before minus 2 will be negative. If you plug any value here in this in x plus 2 here in this term here, any value lower than minus 2, you're gonna have a negative number, negative value out, and after 2 you're having plus and plus, positive. And the same thing's happening to x minus 4. Imagine that you take, like we're having here, you put 3 on it, 3 is in between 2 and 4, minus 2 and 4, you're gonna have a negative number. So you're having a negative and positives just after 4. And for that, because we're having f of x is the multiplication in x plus 1 times x minus 2 or minus 4, f of x will be so we're going to multiply the sign of these two terms. So minus time minus give us plus, plus time minus give us minus, and plus times plus gives us plus. And wherever the function, whatever your derivative is positive, it means that your function, your original function, is positive. That's what we got here. And here the derivative is negative, the original function is negative, decreasing, and here the derivative is positive, our original function is increasing. So the next thing we want to do here is to test the local max or minimum of the function. We can even see that here, right? This is here at minus 2 and here at 4. So, but we can test it to see if it really that one, because remember we just testing the function. And to do that, we need to take this second derivative of the function and plug our 0 value in it to test it. The second derivative of a function is 6x minus 6, or I can factor 6 times x minus 1. So we start with the second derivative of minus 2, f prime prime of minus 2. So we plug in the 0 of the function in the second derivative. F prime prime of minus 2 going to give us 6 times minus 2 minus 1, and this is equal to minus 18, which is smaller than 0. And this means here that we're having a local max at this position, at this minus 2. Therefore, we can say that minus 2 is a local maximum. Okay, that's what we got here. Now we're gonna find test f prime prime of 4, our other 0 of the function. The second derivative of the value 4 gives us here 6 times 4 minus 1. This is here 3 times 6 is 18, and 18 is bigger than 0. It means that we're having a local minimum at this position, at this position 4 here. So we can say that 4 is a local minimum. So, and that's what we got here. Okay, we can just see that on a graph here, we're having minus 2 here is a maximum, local maximum, and 4 is a local minimum. So as you can see, I was actually going to work in this video by first derivative, but I found that I could even show you how to use the second derivative to test the local max and minimum. And actually we could see that here on a graph. It is already to be seen on a graph here, but there's no reason to explain it. So that's what I did. You should, if you don't need to consider this one right here, but it is important to have it. So my title is not, it's kind of messed up, but it's the right one. Just wanted to do something else, to do more additional things to explain it. So this has been for this video. When you got a function, this is what we're talking about. Testing is whether the function increases or decreases a local max and minimum. It's all about taking the first derivative. And when you got the first derivative, you can even see the function here. We have this rate function here is our derivative. Okay, so this is what we're having here. This is our first derivative, and this is this function right here. That's how we got there. And the blue function is our original function. That's the derivative. And you can see the 0 of a function is exactly at 4 here. That's what we got at minus 2 and 4. This is what we got here. Then after, you find the sign of the first derivative, and you can use it at all the and you get this term from the derivative, these two terms from solving the equation. You can use a number line, you can use a table of sign, you can use whatever you want, but this is how it works. Okay, to have that, then I have the two values here, multiply them and multiply the sign here, and wherever my derivative is positive, negative, or positive, there is my original function, positive, negative, positive. Then I can even find the local max and minimum by taking the second derivative. Otherwise I could have left this over. Thank you for watching again. Until next time, bye bye.